Hello, my dear students. Today we will study lesson 2, algebraic fractional function. Algebraic fractional function. From the title, fractional means the function had the form of numerator and denominator. So the function n of x here equal b of x over k of x. B of x is a function and k of x is another function. B of x over k of x together give me n of x is called real algebraic fractional function. From this form, if I have a fraction form, that means I can put any values up and I can put any values down except what? Yes, except 0. So 0 is the value that is not acceptable in the denominator. The only value not acceptable in the denominator is 0. Okay, we will study today the word domain. Domain means what? Domains means the values for x can I put up or down instead of x. What is the numbers or values of x can I put in the function up and down? Okay, we can, as I told you, we can put any values, any real number up and down. I can put any real number except the values of x that make the denominator 0. And we studied in the previous lesson the set of values that can make the function 0 is called what? Excellent. Is called the set of zeros. So the domain of the algebraic fractional function, n of x here, algebraic fractional function, the domain means what is the value of x can we put? We can put any value, or any value means r, different what? Different or minus the set of zeros of the denominator. So we can put any value for x except the value of x that makes the denominator equal 0, and we called it from the previous lesson the set of zeros of the function. So to find the domain of any fractional function, we find the set of zeros of the denominator. And the domain will be r minus this set. For example, if n of x equal x plus 2 over x minus 3, this is an algebraic fractional function. Fractional, why? Because we have numerator and denominator. Okay. We can put any value for x except x equals 3. Why? Because if x equals 3, okay, I have no problem up. 3 plus 2 is 5. I have no problem. But look down here. 3 minus 3 is 0. And we cannot put 0 down because the function will be meaningless, has no meaning, or math error. So the domain will be r. R means all the real numbers minus 3 or minus the set of zeros of the denominator. Again, if I have algebraic fractional function, to find the domain for this function, I will find the set of zeros of the denominator and we write r minus this set. Okay, now go to your booklet, page 38, because 37 will be your homework. The example: determine the domain of the following function, then find f of 0 and f of negative 1. We will go directly to page 38. 37 will be your homework. The algebraic fractional function that I have here, n of x equal 3x plus 2 over x power 3 minus 4x power 2 minus 12x. To find the domain, I will find the set of zeros of the denominators. I have no problem with the numerator. My problem with the denominators, it shouldn't be 0. So, to find the domain, we put the denominator of the function equals 0. X power 3 minus 4x minus 12x equals 0. Look, I have here HCF. X power 3, 4x power 2, 12x. I can take x as HCF, highest common factor. X common factor, open bracket, x power 3 divide x, x power 2 minus 4x minus 12 equals 0. This can be factorized to, I put x as it is. This will be x minus 6 and x plus 2 equals 0. So I have x equals 0, x minus 6 equals 0, x plus 2 equals 0. Here x equals 0, here x equals 6, here x equals negative 2. 0, 6, and negative 2 are the set of zeros of the denominator. So, the domain of this algebraic fractional function n of x equal r minus set of 0, 6, and negative 2. 0, 6, and negative 2 are called the set of zeros of the denominator. What about n of 0 means I will substitute in the function by x equals 0. n of 0 is meaningless because 0 doesn't belong to the domain. If we look to the domain is r minus 0, negative 2, and 6. So 0 doesn't belong to the domain, يبقى n of 0 is meaningless. I don't need to substitute about n of 0 or x equals 0. And n of negative 1, I will replace x and put negative 1. So 3 times negative 1 plus 2 over negative 1 power 3 minus 4 times negative 1 power 2 minus 12 times negative 1 equal negative 1 over 9. So n of 0 again is meaningless because 0 doesn't belong to the domain. Example 2. n of x equal x plus 1 over x power 2 plus 1. To find the domain, I will find the set of zeros of the denominator. So we put x power 2 plus 1 equals 0. X power 2 will be equal negative 1. And x equal positive or negative root negative 1. As we explained before, I cannot find the square root of negative number. It doesn't belong to the set of real numbers. So there is no zeros for the denominators and the domain will be R. I have no zeros for the denominator, so the domain will be all the real numbers. n of 0, substitute in x equals 0. 0 plus 1 over 0 power 2 plus 1 equal 1 over 1 equal 1. n of negative 1 equal negative 1 plus 1 over negative 1 power 2 equal 1 plus 1 equal 0 over 2 equals 0. Example 3. X power 2 plus 1 over 3. Again, to find the domain, I will find the set of zeros of the denominator. The denominator here is constant. There is no zeros for the denominator. And the domain is all the real number. The domain is R. N of 0 equals 0 plus 1 over 3 equal 1 over 3. N of negative 1 equal negative 1 power 2 plus 1 over 3 equal 2 over 3. Let's explain a new kind of exercises in booklet page 39. Number 1, example number 1. If the function n such as n of x equal x plus 2 over x power 2 minus ax plus 25 and the domain of the n is r minus 5. Find the value of a. What is the meaning that the domain is r minus 5? The domain is r minus the set of zeros of the denominator. So 5 here is the value of x that makes the denominator equal 0. First step, I have to take the denominator, which is x power 2 minus ax plus 25, and put it equal 0, and start substitute about x by number 5. Because 5 here is the value of x that makes the denominator equal 0. 5 power 2 minus 5a plus 25 equals 0. 5 power 2, which is 25, minus 5a plus 25 equals 0. I will collect the like terms. But 50 minus 5a equals 0. Negative 5a equal negative 50. And a equal 10. Example 2. If the function n such as n of x equal x plus 5 over x power 2 minus a and the domain of n equal r minus set of 4 and negative 4, find a. Again, the domain of the algebraic fractional function equal r minus what? The set of zeros of the denominator. So 4 and negative 4 is the two values for x that makes the denominator equal 0. So first step, I will take the denominator and put it equal 0, x power 2 minus a equals 0, and start substitution about x one time by 4 and the other time by negative 4. So first, I will put 4 instead of x, 4 power 2 minus a equals 0, or I replace x by negative 4, negative 4 power 2 minus a equals 0. Here, 16 minus a equals 0, and there 16 minus a equals 0. It seems that I have the same value, a equal 16. The last exercise is very important. Number 3, if the domain of the function f, where f of x equal x plus b over x plus a is r minus negative 2, and f of 0 equals to 3, find the value of a and b. Actually, we have two exercises in this exercise. First, I have to find the value of a by using the domain, and we have to find the value of b by substitution about x by 0. First step, I have the domain here, r minus negative 2, or set of negative 2, and negative 2 is the value of x. Yes, excellent, the value of x that makes the denominator equal 0. So my first step to take the denominator x plus a equals 0 and put x equal -2. So -2 plus a equals 0 and a equals 2. After finding the value of a, I will put the value of a in the function. So f of x equal x plus b over x plus 2. And instead of x plus a, we put the value of a. So the function f of x equal x plus b over x plus 2. This is the first part in this exercise. What is the second part? I have to find the value of b, yes. He gave me another information to find the value of b, which is f of 0 equals 3. F of 0 means I will replace x and put 0 and the value of the function will be 3. So f of 0 equals 3. So 0 plus b over 0 plus 2 equals 3. 0 plus b, which is b. 0 plus 2 equal 2 equals 3. So b equal 6. I found the value of a and b. Don't forget to solve your homework. Oh, sorry, before you solve your homework, I have another small part here in page 40. The common domain of two algebraic fractions or more. If I have two algebraic fractions or more, how to find the common domain? The common domain of any number of algebraic fractions equal r minus the set of zeros of the denominators of the fractions. So if I have two fractions, I will find the set of 0 of the first and set of 0 of the second fractions of the denominator, and the common denominator would be r minus the union of set of zeros of the 2 or 3 denominators. Example. Find the common domain of the following algebraic fractions. The first two pairs. The first pair of the fraction here, x plus 2 over x plus 5 and x minus 4 over x minus 7. My method is to find the domain of each fraction first, and we find the domain by find the set of zeros of the denominators. So the first domain, I will take the first fraction, denominator of the first fraction, x plus 5 equals 0, x equal -5. So the domain of the first fraction will be r minus -5. Now go to the second one. Take the denominator, x minus 7 equals 0. So x equal 7, the domain equal r minus 7. What about the common domain? The common domain equal r minus -5 and 7. Or 7 and -5, the ordering is not important. So the common domain equal r minus the union of the domains of the 2 or 3 or more fractions. Example 2. X power 2 plus x plus 1 over 2x and x power 2 minus 1 over x power 2 minus x. First step, I will find the domain of the first fraction by taking out the denominator and equal it by 0. So 2x equals 0 and x equals 0. The domain here is r minus 0. The second fraction, take the denominator, x power 2 minus x equals 0, can be factorized, x by taking out the HCF, x out, open bracket, x minus 1 equals 0, so x may be 0, or x minus 1 equals 0 and x equal 1. The domain equal r minus 0 and 1. And the common domain is r minus 0. I have 0 here. Don't write that 0 twice, just one time. 0 and 1. This is a common domain. So my steps to find the common domain of two or more algebraic fraction. functions is to find the domain of each one, and right in the last step, the common domain is R minus the union of the two or more domains. Exercise 3. I have here 3 fractions. First, I will find the domain of the first one, taking out the denominator, x power 2 minus 5x plus 6 equals 0. Trinomial means I have to factorize, or using the general formula, x minus 3 and x minus 2. You can use the calculator to help yourself to factorize it. X equals 3 or x equals 2. So the domain here are minus 3 and 2. Second fraction, the denominator x power 2 minus 9 equals 0. Factorize x minus 3, x plus 3 equals 0. So x equals 3 or negative 3. We can also use the equation method here to find x. It's both right. So the domain equal r minus set of 3 or negative 3. And the last fraction here, x power 2 plus x minus 2 equals 0, can be factorized to be x plus 2, x minus 1 equals 0. So here, if x plus 2 equals 0, so x equal negative 2. And if x minus 1 equals 0, so x equal 1. The domain here equal r minus 1 and negative 2. What about the common domain? I will write r minus all of these numbers, but without repetition. The common domain equal r minus 1, negative 2, negative 3, 3, and 2. Cannot write 3 twice, just one time. Okay, don't forget to solve your homework in your booklet page 37. Good luck and see you soon.